All right, everyone. So today we're looking at section 6.1, angles of polygons, both internal angle measurements and external angle measurements. For internal angles or interior angles, I'd like for you to think about it in terms of triangles. We're going to derive the equation before we actually talk about the equation. So for interior angles, we've been working with triangles for a while. And triangles, we know, have an interior angle measurement of 180 degrees. Squares, you might also know, to have a measurement of 360 degrees, because each of these are right angles of 90 degrees, and 90 plus 90 plus 90 plus 90 is 360. But we want to think about this in terms of triangles. We can divide up a square, diagonal line, into two triangles. Each triangle with a 180 degree measurement. 180 plus 180 gives me 360 degrees. Pentagon. We might not know off the top of our heads what each of these angle measurements are, but we can divide a pentagon up into three triangles. 1, 2, and 3. And each of these triangles has a measurement of 180 degrees. 180 times 3 gives me 540 degrees. Now, going back to our first triangle, in a three-sided figure, we're able to produce one triangle, and that one triangle has a degree measurement of 180 degrees. In a square, we have four sides that make two triangles, and each triangle has a measurement of 180 degrees, which we multiply by 2, the number of triangles, to get our 360. In our pentagon, we have 5 sides. That make 3 triangles, which we're going to multiply by each triangle's measurement of 180 to get our 540 degrees. Well, the difference between 3 and 1, 4 and 2, and 5 and 3 is the same. It's a difference of 2. So we can essentially think about this, in terms of our interior angles, as the number of sides n minus 2 will give us the number of triangles that we can make in any polygon shape. And if we have the number of triangles we can make from that polygon, and we multiply that by 180, the internal angles of a triangle, we'll get the internal angle of whatever sided figure we have. So 3-side figure, 1 triangle times 180, 1 times 180 is 180. 4-side figure, 4 minus 2 is 2. 2 times 180 gives us our 360. 5-side figure, n minus 2 is 3. 3 times 180 gives us our 540. And so that is basically what our polygon interior angle sum theorem says. That the sum of the interior angle measures for an n-side polygon is going to be n minus 2 times 180. The only other new term that you might not be aware of, convex, small detail, but for the purpose of the explanation, convex means that all the points point outward. So in this square, all of our points, all of our corners are pointing out, away from the interior of the square. That would be a convex polygon. But I can also draw a four-sided shape where we have an internal point, something like that. That internal point makes this a concave polygon. This rule here, our polygon interior angle sum theorem, will not work for concave shapes, only for proper convex shapes. So we can use this equation one of two ways. If we're given the number of sides, we can use it to find the number of interior angles, much like in this worked example. A 13-sided figure given, so our n value is 13. 13 minus 2 means that we can make 11 triangles. 11 triangles times our 180 per triangle gives me an interior angle measurement of 1,980 degrees. We can also use it to find the number of sides by kind of working backwards and using some algebra. Because if we know that the measure of an interior angle, so one interior angle is 120 degrees, find the number of sides, well, one angle times the number of angles there are will give us the interior angle measurement. And in a regular polygon, the number of angles is equal to the number of sides. So if we can find the number of angles, we can find the number of sides. And so the setup for this becomes the known value of our 120 times the number of angles is equal to our interior angle sum theorem, or the number of sides minus 2 times 180. First things first, distributing that 180 to that n and that minus 2 to give us 120n minus 180, 120n is equal to 180n minus 360. Subtracting 180n from both sides to bring all of our variables to the left side of the equation, giving us negative 60n is equal to negative 360. Divide both sides by negative 60. N is equal to 6. So we have a six-sided figure where each interior angle has a measurement of 120 degrees. All right, so let's take a look at some exercises. Exercise 1, the decagon. Decagons have 10 sides, so n minus 2 times 180, or 10 minus 2 times 180, which is 8 times 180, to give us 1,440 degrees. 16gon, that's going to be our n minus 2 times 180. 16 minus 2 times 180. 14 times 180 to give us 2,520. 30gon, n minus 2 times 180. 30 minus 2 times 180. 28 times 180. 5,040. Number 4, an octagon. Octa is 8. N minus 2 times 180. 8 minus 2 times 180. 6 times 180 equals 1,080. 12gon, or dodecagon. N minus 2 times 180. 12 minus 2 times 180. 10 times 180. 1,800. 35 gone. N minus 2 times our 180. 35 minus 2 times 180. 33 times 180 equals 5,940. Of course, if you have questions on these, please be sure to ask via email or in class. All right, so now we're going to do things based on exercise 2. We're going to find the measures, or given the measures of an angle in the polygon, we're going to find the number of sides in the polygon. So if an internal measure is 150 degrees, then what we're essentially doing is 150n is equal to n minus 2 times 180. Distribute that 180. 150n is equal to 180n minus 360. Subtract 150n from both sides. Negative 30n is equal to negative 360. Divide both sides by negative 30. N is equal to 12. Number 8. Internal angle of 160. So 160 times the number of angles is equal to the number of sides minus 2 times 180. So 160n is equal to 180n minus 360. Subtract 180n from both sides. Negative 20n is equal to negative 360. N is equal to 18. Number 9. 175n is equal to n minus 2 times 180. 175n is equal to 180n minus 360. Subtract 180n from both sides. Minus 5n is equal to negative 360. Divide both sides by negative 5. N is equal to 72. $165. So 165n is equal to n minus 2 times 180. 165n is equal to 180n minus 360. Subtract 180n from both sides. Negative 15n is equal to negative 360. Divide both sides by negative 15. N is equal to 24. Number 11. 144n is equal to n minus 2 times 180. Distribute that 180. So 144n is equal to 180n minus 360. Subtract 180n from both sides. Negative 36n is equal to negative 360. Divide both sides by negative 36. N is equal to 10. One more. Internal angle of 35. So 135n is equal to n minus 2 times 180. 135n is equal to 180n minus 360. Negative 45n is equal to negative 360. N is therefore equal to 8. Of course, folks, if you have any questions on 7 through 12, please ask during class or send me an email. Number 13, we want to find the value of x. It looks like a complex problem, but it's actually fairly straightforward. What we're going to do is we're going to first start by counting the number of sides. 1, 2, 3, 4, and 5. 5-sided figure, so we have 5 minus 2 times 180, or 3 times 180, which is 540. So we have an internal angle measurement of 540 degrees. This problem also gives us each of the angles in terms of x. So we're going to add them all up and set them equal to 540. Therefore, 4x plus 10 plus 6x plus 10 plus 5x minus 5 plus 4x plus 5 plus 7x must be equal to 540. Combine some like terms. 4x, 6x, 5x, 4x, 7x adds up to 26x. 10, 10 minus 5 plus 5 plus 20 is equal to 540. Subtract 20 from both sides. 26x is equal to 520. Divide both sides by 26. X is equal to 20. If you have questions on this, please ask questions via email or in class. All right, so let's talk about exterior angles now. Well, in a regular triangle, if we were to extend our sides out, like so, we know that each of these is a measurement of 120 degrees. 120 times 3, 360. In a square, if we extend them all out, we're going to have a measurement of 90, because they're all right angles. 90 times 4, 360. Pentagon, if we extend them all out, they'll be 72. (72 times 5 is still 360. So even though the number of sides is changing as our shapes are getting bigger, the exterior angles is always going to be equal to 360 degrees. Therefore, 360 degrees becomes a constant for dealing with exterior angles of polygons. And that's exactly what our polygon exterior angle sum theorem says, that the sum of exterior angle measures for a convex polygon will always be 360 degrees. It doesn't matter how many sides our shapes have. Example 1 talks about a 27-side polygon, but whether it has 3 sides, 8 sides, 27 sides, 8,000 sides, the exterior angle sum is always going to be 360 degrees. And we can use this with a little bit of division to find the number of sides, the number of angles, the measures of angles, so on and so forth. So, example 2. Find the measures of each exterior angle of a regular hexagon A, B, C, D, E, F. Well, a hexagon has 6 angles. We know that the exterior sum must be 360. So if we divide 360 by 6, each exterior angle must have a 60-degree angle measurement. Or the measure of each exterior angle of a regular hexagon is 60 degrees. That's the extent of the math we're doing for this page. 360 divided by what the number it gives us will end up with the number we want. Now, exercises 1, 2, and 3. Each of these are asking us for the sum of the measures of the exterior angles for a convex polygon. The sum is always going to be 360. Doesn't matter if it's a decagon, a 16gon, or a 36gon, it's always going to be 360. For the rest of them, well, it's simply going to be a simple matter of division, wherein we want to find the measure of each exterior angle given the name of the shape. So a 12gon, well, that's going to be my 360 divided by 12 to give me 30. Hexagon, that's 6 sides, so that's going to be 360 divided by 6 equals 60. A 20gon, well, that's my 360 exterior sum divided by my 20 sides, or 20 angles, because angles and sides are the same in polygons, to give me 18. A 40gon, well, that's going to be 360 divided by 40, which is 9. Heptagon, 360. Heptagons are 7-sided, which is going to be approximately 51.4. 12gon, 360 divided by 12 gives me 30. 24gon, 360 divided by 24 gives me 15. Dodecagon, that's going to be 12. So 360 divided by 12 equals 30. Octagon, that's 8. So 360 divided by 8 is equal to 45. And that, folks, are the extent of the notes. As always, if you have questions, please ask. Otherwise, please complete the assignment for this material.